Hello calculus students, this is Mr. Fugay, and in this video we are going to talk about the product rule, but more specifically what to do when you have a product of three expressions or three functions, however you want to view it. So very quick review of the product rule itself is up here at top. So if you have an f function f of x and multiplying it by g of x, when you take that product, I will take the leftmost term, which is f of x here, rewrite it, but then I will take the derivative of that right term, which that should be in blue. Let's try that again, take two. And then we will take the right term, g of x, and rewrite it, and take the derivative of then that left term, f of x. So I like to say left d right plus right d left, or u dv plus v du. There's all sorts of ways to memorize this, but notice you are, in general, rewriting the function and taking the derivative of one function at a time, rewriting the other function and taking the derivative of the other. So that's exactly what we're going to do for a triple product rule. So you will see now that in this notation we are taking f of x, g of x, and h of x. And what I want you to notice is we're only going to take one derivative at a time. So you'll notice, and I'll highlight these in blue, in this first cluster, we're going to take the derivative of f. In the second cluster, we're going to take the derivative of g. And in the final cluster, we take the derivative of h. The other two functions, g and h, remain unchanged. F and h in the middle, and f and g in the other. So I want you to see these as three separate products. And for each iteration, we are only taking the derivative of one of them at a time. And so that's how I want you to approach the problems below. So I would like you to take a moment right now to pause this video, and I would like you to look down at this example and try to take the derivative of f of x here. No need to simplify. We're not going to simplify these two examples. I really want to just use this time for you to be able to successfully take the derivative. So go ahead and do that now and pause. All right, hopefully you have paused because we are now going to do f prime of x. So first things first, I'm going to go ahead and take the derivative of that left term. So that is going to be 6x minus 0 technically. And then I'm going to rewrite the rest of them. So that's just going to be x plus 4 and then 2x cubed plus 1. All right, first one done. Next, we're going to leave the first term alone, but we are now going to take the derivative of that second term, x plus 4, which is really just a 1. I'll go ahead and write that in red to emphasize it, and then we're going to leave that last function alone, 2x cubed plus 1. And then finally, for that last term, we are going to leave the first two alone, 3x squared minus 4, x plus 4, but then we will take the derivative of that final term, and that's going to be, let's add, is 6x to the second power. So there it is a visual representation of how this works. In the first term, take the derivative. In the second term, take the second derivative. And in that final third term, take the derivative of the third one. So go ahead now, if you need to pause this video one final time and try to do this for g of x. All right, hopefully you've done that because I'm about to go over it. All right, so we're going to take the derivative of the first. Derivative sine is indeed cosine, and then we'll rewrite the other. So cosine x e to the x plus, leave the sine alone. We're going to go ahead and take the derivative of cosine, which is going to be negative sine. I'm going to put that in parentheses to make sure we don't lose that. That negative sign has a tendency to lose or disappear in problems. And then for the last one, we're going to write sine x, cosine x, and then finally we will have, if I can write it here, an e to the x. Now I'm aware that in this one there's probably some things we can simplify. If that was the case, I could, for example, factor out the e to the x, and then that would leave me with cosine squared x minus sine squared x. No, that is not the Pythagorean identity, so even if you thought that, be careful there. And then sine of x, cosine of x. This is probably a more cleaned up version of that function. And that's just really in case you needed to use it for something that's a little bit easier. But the purpose of this video was to be aware that the product rule can extend beyond a product of two terms or two expressions or two functions, and we can use it for three in some situations. Not a common occurrence that you will see in this course, but it is something you need to be aware of. That is all for this video. Thank you for watching.